200 times stronger than steel, but almost invisible to the eye. Graphene is a wafer-thin sheet of carbon atoms with some remarkable properties. It conducts electricity, and when it's printed onto plastic film, it's a flexible and cheap alternative to silicon and metal-based electronics.
It's at the same time very thin and flexible, and an extremely good electrical conductor. That combination of properties is very difficult to find in any other material. And electrical conduction is important as a building block for many of the applications of graphene.
The European Union's spending $1.2 billion over 10 years on research into graphene, a clear sign of its enormous potential. Graphene was heralded as a wonder material when it was first discovered, something which would transform electronics, the way we build cars and aircraft, even the way we make our clothes. However, it's proved difficult to mass produce at quality, which is one of the reasons why mobile phone makers have been slow to adopt it in their devices. That, though, may be about to change. Whether used as sensors in gloves or for printed electronic circuits on flexible film, experimental applications for the material are being demonstrated at this year's Mobile World Congress, and phone makers are interested. Some are doing their own research. But the man who won a Nobel Prize for finding graphene says there are a host of other materials that offer even greater promise.
What we prefer to talk about is the family of 2D crystals rather than graphene alone. And collectively, they hold much more power than only graphene, because where graphene cannot do something, so there are other materials which come instead. And I think that the future is really in the collective usage of those materials in combinations.
The next generation of electronics may be the focus here, but in the years ahead, these one-atom thick materials could see scientists completely re-engineer our material world. Tarek Bazley, Al Jazeera at the Mobile World Congress in Barcelona.